Hi everyone, this video is an exercise 14 of question 2a. So in question 2a we have the equation 2 to the power of 2x minus 6 times 2 to the power of x plus 5 is equal to 0. And we want to solve this sort of exponential equation, but in fact we don't solve this directly because it's just going to be too complicated if we start by taking logs. Um, Well, not necessarily too complicated because it obviously depends on the equation. Sometimes it can get too complicated, but in this case, as you can see, we can easily use the fact that these equations look like quadratics if you really look at this carefully, because here you have 2 to the power of 2x and then here you have 2 to the power of x. So the power of here is just double of that, and then these are the two powers that you have exactly like quadratics. So in this case, the best thing is just solving this by substitution. So you can say that you can basically introduce a new variable. So in this case, we are going to introduce t, which is equal to 2 to the power of x. So because if it's 2 to the power of x, then the first term, which is 2 to the power of 2x, if we want to write this in terms of t, this is simply t squared, right? Because when we do t squared, then this becomes 2 to the power of 2x. And then the second term is just t. So it becomes minus 6t plus 5 is equal to 0. And now we have a very simple quadratic. So we just solve this as usual. And we can factorize this. So t minus 1 times t minus 5 is equal to 0. Therefore, the two solutions. So the first one is t is equal to 1. And the second solution is 5. Now we just set each of these equal to 2 to the power of x. So the first case is when 2 to the power of 2x is equal to 1. And in this case, we just take log of both sides. But interestingly, log of 1 is 0. So what we get is that, let's say we have x log 2, and then here is just log 1, which is 0. So then x is just equal to 0, right? So that's the first solution, that x is simply equal to 0. And then the second solution is when 2 to the 2x is equal to 5. So again, we just take logs again. So we have x log 2. I'm just using the power law that when you have log of 2 to the power of x, and the power can be written outside of the log as a coefficient. So we have x log 2 is equal to log 5. Therefore, x is equal to log 5 over log 2. And since the question has asked to give the answer to three significant figures, this is equal to 2.32. So therefore, these are the two solutions. Now, in part D, we have 3 to the power of 2x plus 3 to the power of x plus 1 minus 10 is equal to 0. So first of all, the middle term might be confusing at the first glance. Because, for example, in the previous case, we had 2 to the power of x, and then here's 2 to the power of 2x. So this one is very nice. But here then you have 2 to the power of 2x, which is fine. But here, instead of having just x, you have x plus 1. But in fact, you can just use a simple trick that this actually converts this equation to exactly the same form as the above one. So you can basically rewrite this as 3 to the power of 2x plus, now here, 3 times 3 to the power of x minus 10. That's because when you have 3 to the power of 1 times 3 to the power of x, then the answer is 3 to the power of x plus 1. And now you have this in that nice form. And again, you can just use the same trick. So we have t, which is in this case equal to 3 to the power of x. Therefore, the equation becomes t squared plus 3t minus 10 is equal to 0. And we can factorize this. So we can have t plus 5 times t minus 2 is equal to 0. So one solution is minus 5, the other solution is positive 2. So the first case is when 3 to the power of x is equal to minus 5. But in this case, we don't have any solutions, right? Because when we raise 3 to any power, the answer is never negative. So it doesn't have any solutions. Then the second case is when 3 to the power x is equal to 2. So you just take logs. We have x log 3 is equal to log 2. Therefore, x is equal to log 2 over log 3. And to the 3 significant figures, this is equal to 0.631.